All right, welcome to The Explainer. Today, we're diving into an AI that might just be a total game changer for science. Seriously. We're talking about a tool that can read a super complex research paper and then just write the code for it. This thing is aiming to solve a problem that has been a major headache for researchers for, well, decades.
So to really get what's going on, we first have to talk about a huge problem, a real roadblock in the world of science and tech. You might have heard of it. It's called the reproducibility crisis. Have you ever seen a headline about some incredible scientific breakthrough and thought, wow, that's amazing, but then you never hear about it again? Well, a huge reason for that delay, that gap between idea and reality, is that the paper might explain what they did, but it often leaves out the how, the actual code to make it all happen. It's usually missing.
And I mean, look at this. This chart tells the whole story. We're not talking about obscure journals here. These are the absolute top tier, the biggest names in AI conferences for 2024. And even there, getting the code is a massive challenge. It's kind of wild when you think about it, right? The very people pushing the boundaries of technology aren't always sharing the keys to their creations.
So when you average it all out, it comes down to this number: less than 1 in 5. Let that sink in. For every 5 brilliant papers published, 4 of them are basically saying, here's what we did, now you figure out how to do it. It forces other brilliant minds to waste their time playing detective, trying to rebuild something from the ground up. And that is what we call the reproducibility crisis. It's this giant traffic jam in the flow of scientific progress. Instead of standing on the shoulders of giants, researchers are stuck in the mud, trying to reinvent the wheel over and over. The spaceship blueprint analogy is perfect. You have the grand vision, but zero clue how to put the pieces together.
Okay, so what if there was a better way? What if you could just give the blueprint to an AI and it would build the spaceship for you? Well, that's pretty much the incredible idea behind this new framework, PaperCoder.
So what exactly is PaperCoder? Think of it less like a single AI and more like a whole team of expert AI developers. Its one job is to take a research paper, digest it, and spit out a complete working code repository. We're talking the whole shebang, all the files, the folder structure, everything you need to just hit run. Now here's the really clever part. PaperCoder doesn't just do a blind word-for-word translation from text to code. No, it's way smarter than that. The whole system is built to mimic how a real human software developer thinks and works. It strategizes, it plans, it handles the details, just like an expert would.
Okay, so you're probably wondering, how does it pull this off without just creating a tangled mess of code? And that's a great question. The answer, the real secret sauce here, is its incredibly structured step-by-step approach.
And this comparison here just nails it. The naive way, just throwing a paper at an AI and yelling, "Write code," that's like trying to build a house by just dumping a pile of bricks on the ground. It's doomed to fail. PaperCoder, though, takes the expert approach. It breaks the problem down just like a real development team would.
It all happens in 3 key stages. First up, you've got planning. This is where the AI creates the master blueprint for the entire project. Next is analysis, where it zooms in and sweats all the small stuff, making sure it understands every little detail. And only after those 2 stages are done does it move to coding, where it actually starts writing the code, piece by careful piece.
And let's be clear, that first planning stage is absolutely critical. This is where the magic really begins. Before a single line of code gets written, PaperCoder digests that dense academic paper and transforms it into a practical, actionable software plan. It maps out the architecture, the file dependencies, the configuration, basically the entire instruction manual. Okay, that all sounds fantastic on paper, no pun intended. But the million-dollar question is, does it actually work? Well, let's dive in and see how it performed when they put it to the test. So in the automated evaluations, where they pitted PaperCoder against other systems, it wasn't even close. PaperCoder consistently generated code that was way higher quality and much more true to the original research. And we're not talking about a tiny little bump in scores here. This was a significant leap forward.
But, automated tests are one thing. What about real people? Well, get this. When they showed the generated code to the actual authors of the papers, the human experts who created the work in the first place, a whopping 92% of them found it helpful. I mean, how incredible is that? The creators themselves are saying, yeah, this AI gets it.
This next number is just mind-blowing. On average, the code it produces is so robust that less than 1% of the lines needed any manual fixes to get it up and running. And we're talking tiny tweaks here, like fixing a typo or updating a library name. The AI basically gets you 99% of the way there,
automatically.
So let's zoom out. What does all of this actually mean? Because this is way more than just a cool new tool for programmers. This has the potential to fundamentally accelerate the entire engine of science.
Really, the big takeaway is this. PaperCoder is a bridge. It closes that massive, frustrating gap between a brilliant idea in a paper and a tangible, working piece of code. By doing that, it could make science more transparent, more collaborative, and just faster. Imagine a breakthrough in medical research getting tested and improved by labs all over the world in a matter of days, instead of months or even years. That's the kind of future this enables.
And so it leaves us with this really powerful question to think about. If we can instantly unlock the code behind any piece of research, if every brilliant idea comes with the keys to its implementation, just how fast can we build the future? What incredible discoveries are waiting just around the corner if we can only remove this one final barrier?